It's difficult for us humans to fully comprehend the enormity of space. We're comfortable in our own cosmic neighborhood, the solar system, and are used to such familiar objects as Jupiter, Mars, and of course Earth. But out there, over 18 billion kilometers away from the Sun and out beyond the heliopause, lies the cold oblivion of interstellar space. The two Voyager probes are the only man-made objects ever to cross this threshold to this day, and until recently only two known objects had ever made the opposite journey, passing from interstellar space into our solar system. These were the famous Oumuamua in 2017 and Borisov in 2019, which brought with them the thrill and perhaps fear of being visited by something from the depths of space that humans cannot hope to reach in our lifetimes. In the 6 years since these visits, we have been enjoying something of a respite, but a recent observation has forced us to look up and pay attention once more. From this post and others, we can see some really exciting images of our new visitor. Just look at these. We've covered the brightness, rotation, and activity of the comet, but what about its surface? Well, in this respect, 3I Atlas is similar to its predecessors. Just like Oumuamua and Borisov, 3I Atlas is significantly redder than the Sun and slightly redder than D-type asteroids like those from the outer asteroid belt. Since it's active, some of the reflected light must be coming from 3I Atlas's coma. The same was observed for Borisov, for instance, where the reflectance of the coma was drowning out the signal from the nucleus itself. We should be able to confirm this as the comet gets closer to us and new measurements can be made. For example, back in 2020, astronomers found that Borisov was producing dust at a rate of 50 kilograms per second, which helped to explain the drowned nuclear signal. Using the LCO telescopes, astronomers identified that the comet has a rotation period of around 29 hours, though like much of the information about 3I Atlas, further observations are needed to constrain this. In a surprise to astronomers, 3I Atlas had a much flatter light curve than Oumuamua and exhibited only 0.2 magnitude of brightness variation throughout the 29-hour period. But despite this minimal variation in brightness, 3I Atlas is bright. In fact, it's the brightest interstellar object we've seen yet. The comet was pretty faint right up until the end of May this year, when it reached a magnitude of around 20. But between then and the comet's discovery by Atlas has promptly increased to between 17.7 and 17.8 magnitude in the Atlas O band, which records light wavelengths between 560 and 820 nanometers. And actually, as of the recording of this video, it's increased all the way up to magnitude 12. So it's actually exceptionally bright for an object that is so far away. So that's fascinating. Not only is the comet bright though, but it's large. From assumed albedo values, the diameter of its nucleus is an estimated 10 kilometers. This makes it an order of magnitude larger than Oumuamua and even larger than Borisov, which measured between 1 and 2 kilometers in diameter. Further observations have also revealed that 3I Atlas shows faint levels of activity. As I mentioned, this comet has a marginal coma, which constitutes the fuzzy glowing halo of dust and gas that is produced when cometary ice sublimates upon exposure to the Sun. You can make it out on the center of this image as a diffuse circle around the nucleus. The image is tracking the moving comet, which is why the surrounding stars appear blurred. But as well as a coma, 3I Atlas has a tail. The MPC reported the tail spanning 3 arcseconds across the sky at an angle of about 280 degrees. This is pretty short, so the tail is often lost among the coma images of the comet. As with many modern scientific discoveries, the advances in technology and communication mean that people around the world can get in on the excitement as well, and that is exactly what's happening for 3I Atlas. Amateur astronomers and experts alike are contributing their own observations of the comet, so our state of knowledge is constantly being updated. For example, the Astronomer Telegram is a forum for space enthusiasts to post their findings, and it's being updated daily with new revelations. Miguel Alarcon and colleagues have helped to constrain the tail measurements for 3I Atlas, reporting that it extends across more than 25,000 kilometers. From this post and others, we can see some really exciting images of our new visitor. Just look at these. We've covered the brightness, rotation, and activity levels of the comet, but what about its surface? Well, in this respect, 3I Atlas is similar to its predecessors. Just like Oumuamua and Borisov, 3I Atlas is significantly redder than the Sun and slightly redder than D-type asteroids like those from the outer asteroid belt. Since it is active, some of this reflected light must be coming from 3I Atlas's coma. The same was observed for Borisov, for instance, where the reflectance of the coma was drowning out the signal from the nucleus itself. We should be able to confirm this as the comet gets closer to us and new measurements can be made. For example, back in 2020, astronomers found that Borisov was producing dust at a rate of 50 kilograms per second, which helped to explain the drowned nuclear signal. From this post and others, we can see some really exciting images of our new visitor. Just look at these. We've covered the brightness, rotation, and activity of the comet, but what about its surface? Well, in this respect, 3I Atlas is similar to its predecessors. Just like Oumuamua and Borisov, 3I Atlas is significantly redder than the Sun and slightly redder than D-type asteroids like those from the outer asteroid belt. Since it's active, some of the reflected light must be coming from 3I Atlas's coma. The same was observed for Borisov, for instance, where the reflectance of the coma was drowning out the signal from the nucleus itself. We should be able to confirm this as the comet gets closer to us and new measurements can be made. For example, back in 2020, astronomers found that Borisov was producing dust at a rate of 50 kilograms per second, which helped to explain the drowned nuclear signal. Finally, the discovery of 3I Atlas has allowed astronomers to make another estimate for just how many interstellar objects there are out there. In a paper published shortly after the comet's discovery, scientists inferred a density of just 0.001 interstellar objects per cubic astronomical unit of space. That's far smaller than the previous estimates made when we discovered Oumuamua and Borisov. This density value is based on the fact that Atlas has been scanning our skies for the past 3 years and has only found one interstellar object so far. But of course the density is liable to change and depends on many other factors. It could be that Atlas has let some objects smaller than 3I Atlas pass by undetected, or that there's a particular signal emitted by these objects that it fails to detect. We're not really sure, but estimates like these are no less useful to us, and we should try to update them whenever we're given the opportunity. So we've explored the information that we've managed to gather about this comet so far, but as we've seen, science is anything but stagnant, especially when there's a brand new toy to play with. So what are we hoping to learn from this comet in the near future, and how can we learn from our previous interstellar visitors? Luckily for astronomers studying 3I Atlas, there are 2 fairly recent case studies to draw from. I have videos about both Borisov and Oumuamua, multiple videos on both of these objects on this channel. So make sure to check those out. I'll link them. And we've already discussed some of the similarities between these objects, but how can these comparisons of the similarities and differences be explained? And what can they tell us about the origins of these visitors? I've touched on one of the major differences already, and that is that 3I Atlas appears to be less active than Borisov was. 2I Borisov displayed significant cometary activity as its dust coma increased in size by around 1% per day, which indicated that it had been active for around 100 days prior to its first observations. It also had a longer tail, spanning 140,000 kilometers into space. Now, it could be that 3I Atlas hasn't been exposed to the sun enough to begin water ice sublimation, and obviously we'll see that with perihelion on October 30th, then when it reemerges from around the sun in December, so lots of new observations to be made before the end of the year. So definitely subscribe and check back on this channel. I'll be doing more update videos for 3I Atlas as well. So lots of developments, lots of new science. So it'll be a really fun time. So definitely make sure to subscribe. And which that would raise the activity levels, water sublimation, but Borisov entered a period of strong activity when it was still 4.5 AU away from the sun, and 3I Atlas is already closer than that, so this looks unlikely, but again, we'll see what happens. And regardless, Oumuamua didn't exhibit high activity levels either. It was a dense rocky body with no ice to sublimate in the glare of the sun, so it had no coma or tail. Astronomers are still trying to explain this lack of activity to this day. Oumuamua is such a fascinating object. Borisov, all these, because we don't know really anything about them. It's a whole new class of objects, so it's so fascinating. And the recent hypotheses are that it may have been outgassing volatilities with a low level of dust production, so it wasn't picked up in observations. But 3I Atlas does have a coma, so this explanation isn't a one-size-fits-all for both interstellar objects. With such differing compositions and activity levels, what does this tell us about the origins of interstellar objects? Well, this is still a major subject of scientific exploration, so I'll definitely be doing future videos about it, so make sure to subscribe for that. The infamous oblong shape of Oumuamua generated a huge buzz around its origins, and theories emerged that it may be a primordial object shaped by tidal forces, or the fragment of a planet, or the aggregation of several smaller objects. I don't believe that they were discussing aliens. I didn't have the channel at the time, so I didn't cover those, but I don't believe they were talking about it being an alien spacecraft or something, in which they're talking about with 3I Atlas. Again, I'll do another video about it, but it's just crazy. It's like whenever there's something that we can't understand in the night sky, we always say it's aliens, so it's kind of wild. So there were all of these theories. Borisov also caused speculation of its own, as its composition was different from those seen typically in solar system comets. Again, that makes sense because we know now at least that it was an interstellar object. So it had a higher abundance of hypervolatile carbon monoxide relative to water, suggesting that it may have been formed in a carbon-rich environment. In line with this observation, it was suggested that Borisov formed in a red dwarf star with cooler average temperatures, cool enough for carbon monoxide to condense and to be incorporated into the comet. But what about the origins of 3I Atlas? So funnily enough, the velocity of the comet that I mentioned earlier can be really useful here. I mentioned that 3I Atlas is traveling at a speed of 58 kilometers per second relative to the sun. Well, it turns out that there is a relationship between the stellar age of objects and their velocity. And assuming that this relationship holds true for 3I Atlas, then the comet could be between 3 and 11 billion years old. That would make 3I Atlas at least 30 times older than Oumuamua and 3 times older than Borisov, hinting at a unique and ancient interstellar origin. Alright, so those are my thoughts on Comet 3I Atlas. It's just a really incredible object. It'll be fascinating to learn more about this class of objects, these interstellar comets, and learn more about what's outside our solar system, what's out in the universe around us, because there's so much that we don't know. So this is a really exciting time. As I said, I'm going to be doing update videos after it reaches perihelion and emerges from around the sun. And just as more science comes out about this object, I'll be doing more videos about Oumuamua, about the Kuiper belt, the Oort cloud, all of that kind of stuff about what's in the universe around us. So if that's something that you're interested in, definitely make sure to subscribe. Alright, so share your thoughts down below, subscribe today, and of course, as always, you can check out some more videos right now.